questions 11 through 20 on the 2017 Grade 10 AMC 10B. At typical high school, 60% of the students like dancing and the rest dislike it. Of those who like dancing, 80% say that they like it, and the rest say that they dislike it. Of those who dislike dancing, 90% say that they dislike it, and the rest say that they like it. What fraction of students who say they dislike dancing actually like it? Let's say there's 100 students, and 60% of them like dancing. And therefore, I guess the other 40 would dislike it. And of the 60 that like it, 80% of them will say that they like it. So 80% of 60 is 48. And therefore, the other 12 obviously would say that they dislike. Because it says that the rest say that they dislike. And then from this group, that group, 90% of them say that they dislike. And then the 90% of 40 is 36. And then the other would be 4. And they would say that they like dancing. So we have to figure out what fraction of students who say they dislike dancing actually like it. Okay, well that fraction, the denominator, are the ones who say they dislike dancing. This and this are the ones who say they dislike dancing, so 12 plus 36 is 48. And then the ones who actually like it among these are these guys. The 12 are the ones who actually like it. So the 12 goes in the numerator, and that is 1 over 4. In terms of a decimal, it's 25%. So number 11, the answer is D. Elmer's new car gets 50% better fuel efficiency measured in kilometers per liter than his old car. However, his new car uses diesel fuel, which is 20% more expensive per liter than the gasoline his old car uses. By what percent will Elmer save money if he uses his new car instead of his old car for a long trip? Well, we have fuel efficiency, and that we can say kilometers per hour, or kilometers per liter, I should say. And for the old car, let's just say it was 10, and the new car is 50% more, so 15 kilometers per liter. And then the cost for the gas, and let's say in the old car, let's say it was $1 per liter, and then now it's 20% more, so $1.2 per liter. Now he's going on some long trip, so let's say he's going on a 30-kilometer trip. For 30 kilometers, he would use, at 10 kilometers per liter, he would use 3 liters. And at 15 kilometers per liter, that fuel efficiency, he would use 2 liters. The cost at $1 per liter, it would be $3. And the cost at $1.2 per liter for 2 liters would be $2.4. And now we have to compare this with this. So 2.4 divided by 3 is 80.8 basically, which is 80%. So that means we saved 20% by using the new car. So number 12, the answer is A. There are 20 students participating in an after-school program offering classes in yoga, bridge, and painting. Each student must take at least one of these 3 classes, but may take 2 or all 3. There are 10 students taking yoga, 13 taking bridge, and 9 taking painting. There are 9 students taking at least 2 classes. How many students are taking all 3 classes? All right, let's make a little Venn diagram, and off we go. And let's label this now. I'll just use straight A, B, C, D type lettering. And what we are asked to find is how many students are taking all 3 classes. So in this diagram, it's basically finding G. All right, let's write our equations. Most of these equations are coming directly from the question stem. A plus D plus E plus G is going to be 10. That's the yoga people. And then we've got the bridge people, and then the painting people. So B plus D plus F plus G is 13, and C plus E plus F plus G is 9. And then we also know that 9 students take at least 2 classes. So D plus E plus F plus G is 9. And then the whole, all of the letters A plus B plus C plus D plus E plus F plus G, well, that is equal to 20, since there's 20 students. So this is the system of equations we have to solve, and it shouldn't be too bad. I'll call this equation 1 and equation 2. What I'm going to do is take equation 1, subtract from it equation 2. And when I do, I get the following, that A plus B plus C is equal to 20 minus 9, which is 11. And then what I'm going to do, the next thing, is add up these 3 guys. And when I add up those 3, I get the following, A plus B plus C plus 2D plus 3G plus 2E plus 2F is equal to 32. Now A plus B plus C I just got was 11, so I put that there. And then I can factor out a 2 and get D plus G plus E plus F, but there's going to be one lone G left over. Well, this guy D plus G plus E plus F, well, that is right here. D, E, F, G is equal to 9, so I can substitute that in. 11 plus 2 times 9 plus G is equal to 32. And therefore, solving, we get G is equal to 32 minus 11 minus 18, and that is 32 minus 29, which is equal to 3. So G is equal to 3, therefore number 13, the answer is C. An integer n is selected at random in the range between 1 and 2020 inclusive. What is the probability that the remainder when n to the power of 16 is divided by 5 is 1? All right, well, we can make a list here of n to the power of 16 and the units digit. And this is going to take a little bit of work, but hopefully we can see a pattern. When n is 1, we have 1, units digit is 1. When it's 2, it's going to be a big long number, but that units digit will be 6. And a lot of these units digits can be found by just looking at a pattern within each number. You don't need to figure out n to the power of 16. You can if you want, but for example, if you did powers of 2, you would be able to figure it out a little bit quickly. Like for example, powers of 2 give the units digits 2, then 4, then 8, then 6, and then 2, and then 4, and then 8, and then 6, like that. So really what you're looking at is just the fourth one, because it's the same every time there's a multiple of 4, and that's how you get 6. So that's a quicker way. So I'll give you another example, 3. Obviously you don't have a calculator on this exam, so 3, then 9 units digit, 7, and then 1, and then it just repeats 3, 9, 7, and 1. So as long as you can see a pattern relatively quickly, you can put what that units digit is, because every time the exponent is a multiple of 4, the units digit will be the same. So 16 is a multiple of 4, so it'll be the same units digit as when the exponent is 4. So you keep doing that pattern, and then you get the following numbers: 6, 5, actually you get 5, and then 7, 6, sorry, there's the next one, you'd get 6, and 7 you get 1, 8 you get 6, 9 you get 1, and then 10, of course, that would be 0. So when we're looking at n to the power of 16 being divided by 5 and then giving a remainder of 1, it gives a remainder of 1 whenever the units digit is 1 or 6. And it seems like it's most of them. The only time it's not is 5, 10, and any multiple of that. So the only numbers that do not give a remainder of 1 when divided by 5, when you take it to the 16th power, are numbers that are multiples of 5. So we have to figure out how many multiples of 5 there are and subtract it from 2020. So this is 404. So the number is 2020 minus 404, and that's how many numbers there are that will give a remainder of 1 when n to the power of 16 is divided by 5. Now they want a probability, so that probability is just 16 divided by 2020, and in lowest terms that's 4 over 5. So number 14, the answer is D. Rectangle ABCD has AB 3, BC 4. Point E is on the foot of the perpendicular from B to diagonal AC. What is the area of ADE? Let's draw a rectangle, and let's label this now. So we got A, B, C, D. They're saying this is 3, and this is 4. So it's a rectangle. And then they're drawing a diagonal from A to C. So like that. And then a perpendicular from B to meet that diagonal. So I guess that would be a perpendicular with a right angle right there. And then that is point E, they're calling it right there. And they want me to figure out what the area of ADE. So I guess this shape right here. Okay. All right, let's proceed here. Let's first draw a line that draws top to bottom like this, and that's going to help me figure out the altitude. This is a perpendicular, so that's a right angle. And I'll call this angle theta, and therefore this angle will be 90 minus theta. And this is a right angle, so this angle here is 90 minus theta, if you're looking at this triangle. So that triangle is similar to this triangle, has the same angles. So using similar triangles, we can conclude that BE over this side right here, which I will just call X, is equivalent to 4 over EC. And therefore, let's fill in what we can, but so far we don't have much here. BE we don't know, X we don't know, EC we don't know. So we're going to need to figure out at least one of these, or both of them. Well, I can figure out the value of AC pretty easily using Pythagoras. That's just 5 because it's 3, 4, 5 triangle. And then the area of this triangle will be 1/2 base times height, which is 3 times 4. But we can also figure it out in another way using this as the base and this as the height. So 1/2 AC is the base, which is 5, times the height, which is BE. And when you solve for BE, you get 12 over 5. Okay, so that's pretty good. That means BE is 2.4. And the next one I would need is EC. And EC I can get using Pythagoras because BE squared plus EC squared is equivalent to BC squared. So that's 4 squared. This is 2.4 squared plus EC squared. And when you do this math, you get EC is equal to 3.2. All right, so now I can go back to this guy. And when I do, I get 2.4 over X is equal to 4 over 3.2. Solving for X, I get X is equal to 1.92. And now I can easily figure out the area of this. If from here to here is 1.92, then from here to here would be 3 minus 1.92, since that is 3. And 3 minus 1.92 is 1.08. So finally, the triangle ADE, that area is 1/2 base times height. The base is 4. The height is 1.08. And that is 2.16. In fractional form, it's 54 over 25. So number 15, the answer is E. How many of the base 10 numerals for the positive integers less than or equal to 2017 contain the digit 0? All right, so my number is between 1 and 2017 inclusive. So let's break this up. Let's talk about one-digit numbers first. And one-digit numbers, well, they're either going to be anywhere from 1 to 9, and none of those have a 0 in them, so 0. And this is the tally, I guess, of how many we are counting. All right, let's move over to two-digit numbers. A two-digit number could definitely have a 0. It could be, it's of the form like this. Now this one can't be 0, the first digit, only the second digit. And the first digit can be anything from 1 to 9. So it looks like we've got 9 of those, 10, 20, all the way up to 90. Okay, now we get up to three-digit numbers that have a 0. Okay, so there's going to be a few different forms. The first form is when the 0 is here, 0 is here, or the zeros are there. Can't have a 0 here because that would not be a three-digit number. If the 0 is just there, we've got 1 to 9 here, 1 to 9. So I've got 9 choices, 9 choices. 9 times 9 gives me 81. Similarly, I can put any number from 1 to 9 there, any number from 1 to 9 there. 9 choices, 9 choices. 9 times 9 is 81. For this one, I can only put numbers from 1 to 9 in one slot, so I only have 9 choices there. All right, moving right along. Now we get into our four-digit numbers. And I'm only going to go from from 1 to 2000 here for the four-digit numbers. And at the end, I'll add up the 2001 to 2017. Well, that's pretty straightforward. That's just 17. So those guys are 17. But we'll do that at the end. Making it this range makes it a little bit easier. Okay, so we got four-digit numbers now. What are the formats? All right, so the first, the 0 can be here, or the 0 could be here, or the 0 could be here. Then you can have two zeros. You can have, say, 0, 0 like that, 0, 0 like this, or 0, 0. And then finally, 3 zeros like that. Okay, so the first scenario, this number here has got to be only a 1. You can't put a 2, because if you put a 2, the number is going to be greater than 2000, because these numbers are not 0, 0. You see what I mean? So that's why I only made it in this range, because it just makes it easier. Here I can put any number from 1 to 9, any number from 1 to 9. So this is fixed as 1, only one choice. 9 choices here, 9 choices there. 9 times 9 is 81. Okay, same story here. The only choice is 1, 1 to 9, 1 to 9. 9 times 9, 81. Only choice here is 1, 1 to 9, 1 to 9, 81. All right, this guy. Only choice here is 1, 1 to 9, 9 here. Only choice here is 1, 1 to 9, 9 here. 1, 1 to 9, 9 here. Now we get to this one. Here I can put a 1 or a 2, because the 2 would make it 2000, which is within that range. So I've got two choices there. And then, as promised, we have to add those 17. So now we've got to add all these numbers plus this 17. And when you do, you get a grand total of 469 for number 16. Choice A. call a positive integer monotonous if it is a one-digit number, or its digits, when read from left to right, form either a strictly increasing or strictly decreasing sequence. For example, 3, 2, 3, 5, 7, 8, and 9, 8, 7, 6, 2, 0 are monotonous, but 8, 8, 7, 4, 3, 4, and 2, 3, 5, 5, 7 are not. How many monotonous positive integers are there? Well, we have two possible scenarios. The first is when they are ascending in order, the digits, and the second one is when they're descending, the digits. So, the ascending one, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't start with a 0 because you can't start a number with a 0. Now, there's a very interesting way of looking at this. Any number can include either all of these or some of them. So we can either include the number or exclude the number. And which numbers am I talking about? I'm talking about each of these. So, for example, if I included all of them, the number would be this big long number. If I excluded, say, the 3, the number would be that number without the 3. So, if I include or exclude the numbers, it would still be an ascending monotonous number. And that's, in my opinion, the easiest way of thinking about this. So for each of these, I can either include the number or I can exclude it. So I have two choices. I can either include the 2 or not, or exclude the 2. Two choices. Include or exclude two choices, and you get the point. So the total number of ways of creating a monotonous number that is ascending is 2 times 2 times 2, essentially 2 to the power of 9. But there's one scenario that does not work, and that is when you exclude all. If you excluded all the numbers, there's no number. That would be what is known as an empty set. An empty set obviously is not going to work. So that one, variation is not something that works. So you have to subtract that from 2 to the power of 9. And when you do, this number is 511. All right, so I hope that makes sense. In a very similar way, now we're doing descending. So 9, 8, 7, 6, 5, 4, 3, 2, 1. But you can also put a 0 at the end. That's allowed. Zeros are definitely allowed. Same thing. Any number of this form is a monotonous number that's descending. And it can also stay as a monotonous number if you include or exclude any of these. So for example, if I took out the 6, it still would be a valid descending monotonous number. If I took out the 3 and the 8, it would still be valid, and so on, right? So for each of these, I've got two choices. Either I include or I exclude. So the total number here is 2 to the power of 10, because you have to multiply them, right? But as before, there's actually two that don't work. The first one, just like before, is if you excluded all of them. If you exclude all, then there's nothing left. You just get an empty set. So that scenario has to be subtracted from 2 to the power of 10. There's one more that has to be subtracted, and that is if you excluded everything but only included a 0. So you excluded all the numbers but kept only the 0. Well, that doesn't work because the number has to be a positive integer. And 0 is not positive. So I've got to subtract that one also, because it's not positive. So minus 1 again. And then 2 to the power of 10 minus 2 is 1022. So I've got to take this and I've got to add it to that. So I get finally 511 plus 1022. But I'm still not done. Why? Because in both of these sets, this one and this one, they include the single digit numbers, both of them. If you, for example, excluded everything except the 9, you're going to get a 9. And same thing here, if you excluded everything except the 9, you'd get a 9. So the single digit monotonous numbers are included in both lists. And there's a 9 here and 9 single digit there, so we have included them twice, so we have to subtract them from this overall list once, since there's 9 and 9 and they're both the same. So this is finally the number, and this is 1524. So after all that, we got the answer, and that for number 17 is B. In the figure below, 3 of the 6 discs are to be painted blue, 2 are to be painted red, and 1 is to be painted green. 2 paintings that can be obtained from one another by rotation or a reflection of the entire figure are considered the same. How many different paintings are possible? Here you go. Here's the possibilities, and this is one of those questions where you just have to fiddle around and make sure that you don't overcount, because some of them, as they mentioned in the question, if you reflect it or rotate it, they look exactly the same. So these ones that are listed here are the unique ones that you cannot reflect and make one to look like the other. So as you can see, the G is for green, the R is for red, and the blank ones are the ones that would be painted blue. So for example, this would be blue, 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 and so on. So as you can see, there's 12 of them, and therefore number 18, the answer is D. Let ABC be an equilateral triangle. Extend side AB beyond B to a point B prime, so that B prime is 3AB. Similarly, extend side BC beyond C to point C prime, so that C prime is 3BC, and extend side CA beyond A to a point A prime, so that A prime is equal to 3CA. What is the ratio of the area of triangle A prime, B prime, C prime to the area of ABC? Here's that diagram, A, B, C, and then we extended it to create B prime, C prime, and A prime like that, and then we joined them to create these triangles. And entirely based on the information in the question, if AB, for example, is x, B prime is 3x, and similarly, if this is x, this would be 3x, and if this is x, this would be 3x. And we know it's XXX because it's an equilateral triangle. They told us that. All right, well, several ways of approaching this question. What we have to do basically is figure out the areas of both triangles, the one in the middle and then the big one, and then compare their areas. Okay, well, the one in the middle is pretty straightforward. We can just figure out in terms of a ratio. And you've done that so many times that it's painful to go through it again. You draw a altitude, and based on the fact that it's a 30, 60, 90 triangle, you can easily get the height. So, for example, h over x is the same as root 3 over 2. And that's because of the ratio of the sides of a 30, 60, 90 triangle. So h is equivalent to root 3 over 2x. So the area of that triangle is 1/2 base times height. The base is x. The height is h, which is root 3 over 2x. So this is root 3 over 4x squared. And then now I'm just interested in finding just one side, because I'm confident that A prime, B prime, C prime is also equilateral. So I can use the same sort of story, but I need to find at least one side. Okay, well, I can do that using the cosine law on this triangle right here. And since this is 60 degrees, this will be 120 degrees. So I'll just call the side y, and therefore y squared would be 3x squared plus this side squared, which is 4x squared, minus 2 times 3x times 4x cos 120. So that is 9x squared plus 16x squared minus 24x squared, and then the cos of 120 is negative a half. So that's 25x squared plus 12x squared. So y squared is equal to 37x squared, and therefore y is root 37x. So in a very similar way, we can figure out the area of that big guy. So the big guy, the same thing, its altitude over y would be root 3 over 2, and therefore its altitude would be root 3 over 2y, like that. Same story. So the triangle A prime, B prime, C prime would be 1/2 base times height. The base is y. The height is root 3 over 2y, and therefore root 3 over 4y squared. And then now the ratio of the area of this triangle to that triangle would be root 3 over 4y squared over root 3 over 4x squared, since I have figured that out earlier. And this just reduces to y squared over x squared. And we know that y is equal to root 37x. So root 37x all squared over x squared. And this is 37x squared over x squared. And that is just 37 over 1, if you really wanted to put that 1 in there. And that's it. Number 19, therefore, the answer is E. The number 21 factorial is equal to this. It has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it is odd? All right. Well, what I want to do is I want to write out 21 factorial in its prime factorization. Okay, well, it takes a little bit of work. I have to first look at every one of those numbers from 21 to 1. All right, well, 21, let's do this quickly. 3 times 7, 20 is 2 times 2 times 5. 19 is just 19 because it's a prime. 18 is 2 times 3 times 3. 17 is a prime. 16 is 2 times 2 times 2 times 2. 15 is 3 times 5. 14 is 2 times 7. 13 is just a prime. 12 is 2 times 2 times 3. 11 is a prime. 10 is 2 times 5. 9 is 3 times 3. 8 is 2 times 2 times 2. 7 is a prime. 6 is 2 times 3. 5 is a prime. 4 is 2 times 2. And 3 is a prime, and so is 2, and 1 is just 1. Okay, so now I can break it up into prime factors. So 2, we got to now circle all the 2's. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 2 to the power of 18. All right, great. Next one would be 3. Let's circle the 3's. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's a 3 there hiding. So that is 3 to the power of 9. Now let's do what's next. 5 would be next, right? So 5's 1, 2, 3, 4. So I think only 4. What's the next prime number? 7. Let's see here. 1, 2, 3. I think just 3 for 7. And the remaining ones, 11, 13, 17, and 19. There's only 1 of each, as you can see. There's only 111, 113, 117, and 119. So these exponents will just be 1. And these are all multiplication, by the way. All right, so now we have the prime factorization of 21 factorial. And to figure out the number of divisors, we have to do the following. You take this and add 1. So 18 plus 1. Then you multiply by this plus 1. 9 plus 1. And then you multiply by this plus 1. And you get the point. So then it would be 3 plus 1. And then a whole bunch of 1 plus 1s, right? 1 plus 1, 1 plus 1, 1 plus 1, and 1 plus 1. And that is 19 times 10 times 5 times 4 times 2 times 2 times 2 times 2. And when you do this multiplication, you get 60800. Indeed, over 60,000. And I wanted to show you that. But what we are being asked is if you choose one of these 60,800 divisors, what is the probability that the divisor is odd? Okay. Well, a divisor will be even if it has any of these 2's in it. It's the only even number in this breakdown. So if you took that out and then just looked at the rest, any divisor that is produced by the rest would be odd, since all of those are odd. So that means that you would have to essentially create divisors with just these prime factors and their exponents. So that would basically be 9 plus 1 times 4 plus 1 times 3 plus 1 times 1 plus 1, 1 plus 1, 1 plus 1, and 1 plus 1. These are the only divisors that do not include the 2, and therefore these are odd. So this would be the number all over the full number, which I had already written here, which was 18 plus 1, and so on. Well, the good news is everything cancels. Everything cancels except this 18 plus 1, and that is 1 over 19. So this is a very good question. I encourage you to understand it because it will definitely come up again and again on math contests. So number 20, the answer is B.